Pick any number at all. If it is even, divide it by 2. If it is odd, multiply by 3 and add 1. Now repeat. Keep going. You will always end up at 1. Every number ever tried ends at 1. Nobody knows why. That is not a joke. That is an unsolved problem in mathematics. Let's try it with 6. 6 is even, so divide by 2. You get 3. 3 is odd, so multiply by 3 and add 1. You get 10. 10 is even. Divide by 2. You get 5. 5 is odd. Multiply by 3 and add 1. You get 16, then 8, then 4, then 2, then 1. Done. Landed on 1. Simple enough. Almost boring, actually. So let's try something bigger. 27. Seems fine, right? Small number. Should be quick. 27 takes 111 steps before it hits 1. At one point, it shoots up to 9,232 before collapsing back down. A number that starts at 27 climbs to 9,232 before it surrenders. That is not boring. That is chaotic. Here is what makes this dangerous. Every number that has ever been tested, and mathematicians have tested up to 2 raised to the power of 68, ends at 1. That is 295 quintillion numbers. All checked. All end at 1. But nobody has proved it works for every number. Because checking numbers is not a proof. You can check 1 trillion numbers and still have no idea what happens at number 1,000,000,001. This is called the Collatz Conjecture, named after Lothar Collatz, who proposed it in 1937. He thought it would be solved quickly. It has now been open for 87 years. At this point, Collatz probably owes mathematics an apology. The reason this is hard is not because the rule is complicated. The rule is 2 lines long. The reason it is hard is because the sequence is completely unpredictable. Some numbers collapse quickly. Some shoot up before coming down. There is no pattern anyone has found that tells you in advance what a number will do. Mathematicians have tried attacking it with number theory, with computer science, with chaos theory. Nothing works. Paul Erdos, one of the most prolific mathematicians in history, said this about the Collatz conjecture. That is the mathematical equivalent of a doctor looking at your X-ray and quietly leaving the room. There are only 2 ways the Collatz conjecture could be false. Option 1. A number exists that eventually cycles back to itself without hitting 1. It goes around in a loop forever, never landing. Option 2. A number exists whose sequence goes up forever, just keeps climbing, never comes back down. Nobody has found either, but nobody has proved they cannot exist. And in mathematics, we have not found it yet is not the same as it does not exist. In 1952, a mathematician named Brian Thwaites offered a cash prize to anyone who could prove or disprove the Collatz conjecture. The prize is still unclaimed. Here is the strange part. The rule fits on 1 line. A child can understand it. You could explain it to your grandmother in 30 seconds. And it has defeated every mathematician who has tried it for nearly a century. Some problems are hard because they are complicated. This one is hard because it is simple. Pick any number. Divide by 2 if even. Multiply by 3 and add 1 if odd. Repeat. You will always reach 1. We just do not know why.